Good morning, algebra. So we are starting a brand new unit. It's the first part of chapter 6. It starts off with a little bit of review because we're going to be talking about exponents for the next few weeks, all right? So just a reminder about what exponents are. So we're going to write out each expression and what it means. So this right here, we have 2 to the third power, or sometimes we say it 2 cubed. We know that 3 up there really means that we have 3 2's that are being multiplied together, right? So it's really 2 times 2 times 2. And that exponent is just a shorter way of writing that. Kind of like multiplication is a shorter way of adding things together, right? Instead of saying 4 plus 4 plus 4, we would say 4 times 3. Because that's shorter, but we know what we're doing. We're doing repeated addition when we multiply. And in this case, with exponents, we're doing repeated multiplication. So 2 times 2 times 2. Well, if we actually do that, 2 times 2 is 4, times 2 is 8. Now, it matters what the exponent is touching. Okay, it matters what the exponent's touching. We're going to look at these two as an example of that. So we're going to start with this one up here. With this one, we've got -3, and the -3, all of it is being raised to the 4th power. So what that means is that everything inside the parentheses, I'm going to write out 4 times. So -3 times -3 times -3 times -3. Right? And you can put parentheses around them if you want to. You don't have to, because we know that parentheses just mean to multiply, and I've got my little multiplication symbols in there. So either way works. And so when we actually do this, we get -3 times -3 is a positive 9, right? So that'd be 9 times 9. Wait a second, 9 times 9 is really 81. And you'll notice the negative times negative is a positive. So it's really important that you write it out this way, because it's everything inside that multiplication, or that parentheses that's being multiplied, right? But down here with this one, that exponent, that 4, is not touching the negative sign. It's only touching the 3. So when I go to write this one out, I'm just going to leave my negative out front, and then I'm going to have 3 times 3 times 3 times 3, because it's only touching the 3. It's not touching the 4. This one is touching both, right? It touches everything inside the parentheses. This one, it only touches whatever number it's attached to, and it's only attached to the 3. So when I go to rewrite this one, I'm going to leave my negative sign out front, and then we know that 3 times 3 is 9, and 3 times 3 is 9, so this is going to be 9 times 9, which gets us 81. So that's a really important distinction right there to make, all right? That's a really important distinction to make. So I want you guys to try these next 3 on your own, okay? Pause the video, try those out. All right, so for this one, you should have gotten -2 times 2 times 2 times 2 times 2, which really is -32. With this one, it would be 4 2's being multiplied together, which is 16. And then with this one, I wrote that one out. There it is. We have -4 times -4 times -4 times -4. 4 times 4, -4 times -4, is 16. 16 times 16 is, I missed -4. There we go. So this is -1024. All right, I'm going to slide this up. All right, so these are some more to practice. It says to simplify on there. So for example, I could write out that this would be 10 times 10 times 10, or I know that it's going to be 1,000. Same thing with this one. This is 5 times 5 times 5. No, it's 125. So I'm going to encourage you to try some of these out. There's lots on here to try. I would pick 5. All right, pick 5 to try. And now check your notes for the answer. So we're going to start off with our first rule. All right, there's a total of 6 of them for these exponents. And at the end, I'll give you kind of a sheet that summarizes it all. But for now, we're just going to go through the rules. So the first rule is the product rule. So if you have the same base, you can add the exponents. All right, if you have the same base, you can add the exponents. If the bases are different, then you can't add them. So, for example, if we take a look up here, if you have a to the m, actually, let's go with this one. If you have 3 to the 4th times 3 squared, that's really 3 to the 4 plus 2. So that'd be 3 to the 6th. And you might look at me and go, well, how do you know you can do that? And I'm going to show you with this first one here. I'm going to write out what these really, really mean, okay? So 2 to the 5th and 2 to the 6th, that would be 2 times 2 times 2 times 2 times 2, right? There's 2 to the 5th. And now for 2 to the 6th, times 2 times 2 times 2 times 2 times 2 times 2. Okay, so how many 2's do we really have there? Well, let's go through and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is really 2 to the 11th. Well, how do we get from 2 to the 5th to the 6th and 2 to the 6th to 2 to the 11th? We had to add those exponents, right? So this is really 2 to the 5 plus 6 equals 2 to the 11. So you can write it all out this way and then just count them all up. But the shorthand way of doing it, the efficient way of doing it, is just to say, oh, let me add the exponents because I'm multiplying them together, right? This is a product. And the product rule says if they have the same base, aka if it's the same number that's our base right here, then we can add the exponents. And remember, a base is whatever the number is, and then the exponent is whatever it's being raised to, right? I know you guys probably know that, but I just want to be very explicit about that. So we're going to try some more of these. This one, for example, when we have multiple different kinds of numbers or variables, I find it helpful to write them together. So to list them out, I like to go alphabetical or numerical. So I'm going to do my 3's first. So 3 to the negative 2 times 3 to the 6th times 4 squared times 4 to the 5th. And now that it's like that, it's a lot easier for me to see. So I would do 3 to the negative 2 plus 6 times 4 to the 2 plus 5. Right? I'm just adding my exponents together. So this becomes 3 to the 4th times 4 to the 7th. And yes, you can have negative exponents. We'll get into what that means later on, but just now, for now, know that it's possible. It's possible to have negative exponents. All right, let's try this one next. Again, start off alphabetical. So a to the 4 times a squared times b to the 5th. Then I can rewrite that a to the 4 plus 2 times b to the 5th. A to the 4 plus 2 is really going to be a to the 6th times b to the 5th. So our b didn't really do anything. He just kind of hung out, right? And that's okay. Sorry, I forgot to add that one on there. I'll make sure I add it to your guys' notes. Let's do this one next, mostly because I want to talk about if you have y. How many y's do you have there? What's the exponent of that y? Because it has an exponent. He's a ninja. You don't always see him, but he's always there. So in this case, there is actually a 1 there. So this would be y squared times y to the 1 times y to the 4th. Our product rule says same base, add the exponents. Well, these are all the same base. They're all y's. So it would be y to the 2 plus 1 plus 4. 2 plus 1 is 3, plus 4 is 7. All right, let's do this one next. You'll notice that these b's have coefficients. When we have coefficients, pretend that, not pretend. You guys know what to do with coefficients, like if you had 2x times 3x, right? We multiply our coefficients together, and then we figure out the exponents. So what we're going to do with this one, 2 times 3 would be 6, and then x and x would make x squared. We're going to apply the same principle here. So we have 2 times 9, which is 2 times 9, and then we have b to the 6th times b to the 4th times g squared. So 2 times 9 is 18, and then we would do b to the 6th plus 4 and then times g squared. So that gets us 18 b to the 10 g squared. And I personally do like to list these out. We always write the coefficients first, but I like to have it in alphabetical order as well. So I like the b to go next and then the g. Some teachers prefer it to be in like the highest exponent goes first. So it kind of depends. All right, let's try this one next. So we have an m to the 1 there, so it'd be 1 plus 4, and then times n to the negative 4 plus 6. So we would get m to the 5th, n to the 2. All right. All right, so there are plenty more to choose from. I want you guys to try at least 5 more on this page. And try to pick from the ones that are lower down. So pick 5 more on this page. All right, I'm going to pick from the very bottom here. I'm going to do this one first and then this one. So with this one, again, rewrite it. So 3 times 9, right? Do your coefficients. And then we've got a k times k to the 5th. And then n cubed times n to the 4th. Well, 3 times 9 is 27. This would really be k to the 1 plus 5. Don't forget that 1. He's ninja, but he's there. And then n to the 3 plus 4. So we would get 27 k to the 6th, n to the 7th. All right, this one down here. Again, start with your coefficients first. So 8 times 9. And then I'm going to do my c's. So we have c to the 4th times c to the 4th times just a c. And then we have d's. D to the 6th, d cubed, and d squared. Well, 8 times 9 is 72. And then we have c to the 4 plus 1. Don't forget that 1 in there. And then we have d to the 6 plus 3 plus 2. So this is really 72, c to the 9, d to the 11. So that's the product rule. The next rule we're going to learn about today is called the quotient rule. All right. So when we have the same base, we can subtract the exponents. All right. When we have the same base, we can subtract the exponents. So here's what that means and why we can do that, really. So for this guy right here, I'm going to write it out long ways so you can see what I mean. So 3 to the 8th is really 3 times 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 3. And then it's being divided by 3 squared, right? So that'd be really 3 times 3. Now, I know that if I have the same numbers in my numerator and the denominator, then I can just cancel them out, 1 them out, right? So I'm going to do that. So this 3 and this 3, 1 out. This 3 and this 3, 1 out. Well, what am I left with? I am left with 1, 2, 3, 4, 5, 6. 3 to the 6th. So when we take a look at that, we had 3 to the 8th divided by 3 squared, and we ended up with 3 to the 6th. What did we do to our original to figure out 3 to the 6th? Hopefully you can see that all we did was go 3 to the 8 minus 2, and that equals 3 to the 6th. So you can write it out long ways. All of these rules just help us simplify it, right? They help it go quicker. So when we have the same base, we can subtract our exponents. That's the quotient rule. So for this one, we've got x to the 5th, and then I need to subtract 3. So that would leave me with x squared. I find it very, very useful to separate these out into my a and b in this case. So for example, this would be a to the 5th, b to the 9th. This 4 is touching everything inside it. So this is really a to the 4th and b to the 4th, right? So we would have a to the 5 minus 4 and then b to the 9 minus 4. So this is really just a and b to the 5th. All right, let's try this one out. So for this one, we would have 2 to the 3 minus 1, right? He has a 1 for an exponent. Then we'd have 3 to the 2 minus 4, and then we would have 5 to the 7 minus 5. So we would get 2 squared, 3 to the negative 2, and then 5 squared. All right, I'm going to slide it up a little bit more. And let's take a look at these two next. So for this one, we actually have coefficients. So we're just going to leave those as they are. So the 4 will stay on top and the 8 will stay down there. If we can simplify them, we will. But first, let's worry about our other exponents, okay? So we've got an s to the 23, and then we need to subtract the 6th. And then we've got a t to the 14, and we need to subtract the 8. So I know that 4 is really 2 times 2. So I can actually divide that by 4 for both the top and the bottom. So we're left with 1 over 2. Do I need to write that 1? No, he's a ninja. I like to because it helps my brain. And then s to the 23 minus 6, that would be s to the 17. And then t to the 14 minus 8 would be to the 6th. All right, so another way of saying that would be s to the 17th, t to the 6th over 2. Or 1/2 s to the 17th, t to the 6th. So there's many ways of doing it. All right, this one is the next one I want us to look at. We've got 7 divided by 2 there. It just hangs out. I mean, you could write a decimal, but don't. Fractions are always better, remember? So 7 over 2. And then we've got an a cubed minus 2. And we've got a b to the 9th minus negative 5. Okay, that's really, really, really key. We always subtract. Even if the exponent we're subtracting is a negative, that's fine. You must always subtract for the quotient rule. When you're dividing, we always subtract. So this gets us 7 over 2. A to the 3 minus 2 is really just a, and then b to the 9 minus negative 5, that's really plus. So this would be 14, right? Because this is really a plus. All right, I'm going to slide this up a little bit more. So try 5 more on this page. I would skip this one and come back to it because we're about to learn that rule next. So try 5. All right, the last rule for today. There we go. And hopefully you guys are looking at these going, yeah, no, this totally makes sense. This totally makes sense. This is called power of powers rule, all right? So it says whenever you have the same base, you are going to end up multiplying the exponents when you raise a power to a power. So I want you to see what I mean. And I'm going to write this out not entirely long ways, but much longer. So we've got 7 to the 4th raised to the 3rd power. So that means that everything inside the parentheses here, I'm going to have 3 times. So that means I'm going to have 7 to the 4th times 7 to the 4th times 7 to the 4th. Now we just learned the product rule when we're multiplying these all together, and that says we would add our exponents, right? So we would have 7 to the 4 plus 4 plus 4. So this is really 7 to the 12th. Well, where did that 12 come from? If we just take a look, is there an easier way, a shorter way of doing this than having to write that all out and add them together? Yes, there is. The shorter way is to say, oh, if I multiply these exponents, I find my answer. So with this one, for example, we've got 3 to the 6 times 2. Now our base is going to be 3, so I'm just going to write that. And then 6 times 2 gets us 12. So that's the answer. All right, so for this one, we've got 3 to the 4th raised to the 5th power. So that'd be 3, 4 times 5. So that'd be 3 to the 20th. All right, this last one on the top row here, we're going to have to combine some of our rules. So we've got a to the 3 times 4 times a to the negative 2 times negative 3. Well, 3 times 4 is 12, and then negative 2 times negative 3 is 6. And now I can just add them together, right? A to the 12 plus 6, that gets us a to the 18. All right, so I want you to take some time and to try these out. All right, pick 5 of them to try. You can see all of them on the page now. All right, I want us to do this one together for sure. All right, so we've got x times y. This becomes x squared to the 3rd power is really x to the 2 times 3. And then y cubed to the 4th power becomes y to the 3 times 4. So this is really x times y times x to the 6th times y to the 12th. I'm going to rewrite that so my x's are first, so x times x to the 6th, and then my y's come second, so y times y to the 12th. Remember, this is really has 1's there, so that'd be x to the 1 plus 6 and y to the 1 plus 12. So we end up with x to the 7th, y to the 13th. All right, email me if you have any questions about this, but this is our first set of rules. So hopefully you find these pretty logical. And if you need to, you can always write out long ways like we were doing. I just would not recommend it. It's going to take you a long time.